Welcome to this video. Today we will take a closer look at how to work with Qt widgets using GetQtProperty and SetQtProperty in Zeno Test. Instead of recording mouse clicks, we will directly read and modify Qt widget properties using a simple ComboBox example. For this demonstration, I've prepared a small Qt-based test application. The application contains a single QComboBox with 4 items, 1, 2, 3, and 4. Internally, the ComboBox is created using standard Qt code, and the application is compiled and configured as the application under test, or AUT in Zeno Test. In this example, we are starting from an already prepared project. The project file Qt Test ap.zproj is already configured and loaded in Zeno Test. It contains the test suite Qt ComboBox tests and the test case read and modify ComboBox. The application under test is also already defined. The Qt Test app executable is selected in the AUT tab and ready to be used. We can still click Open AUT to verify that the application starts correctly. This confirms that the AUT configuration is complete and ready for automation. Before we continue, there is one important prerequisite to mention: the functions. GetQtProperty and SetQtProperty are available for all Qt applications built with Qt version 6 or newer, using either MSVC x64 or MinGW x64. If your application meets these requirements, Zeno Test can directly access Qt widget properties using the Qt meta object system, without relying on recorded UI actions. With these prerequisites fulfilled, we can now focus entirely on reading and modifying the ComboBox using Qt properties. Before we continue, we need to make sure that Zeno Test can identify the Qt ComboBox as a control. For this, we switch to the Controls tab and enable the option Start AUT automatically. This ensures that the application under test is launched automatically when recording. After that, we start the recording. Zeno Test now launches the Qt Test app and waits for user interaction. To register the ComboBox control, we simply click once on the ComboBox inside the application. This single click is enough for Zeno Test to detect the widget and add it to the list of controls. No further interaction is required. We are not interested in recording user behavior here. We only want to capture the control itself. Once the ComboBox has been detected, we stop the recording and close the application. The ComboBox is now available as a named control and can be accessed later using GetQtProperty and SetQtProperty. Now let's take a look at the script itself. As with every Zeno Test script, execution starts in the main function. At the very beginning, we call startAUT to launch the application under test. We now use GetQtProperty to read internal properties of the ComboBox. First, we read the total number of items using the count property. Next, we read the currently selected text using currentText. And finally, we check whether the ComboBox is editable by reading the editable property. After reading the Qt properties, the next step is to verify that the widget is in the expected initial state. First, we verify the number of items in the ComboBox. By checking that the count value equals 4, we make sure that all expected entries have been added correctly. Next, we verify the currently selected text. At application startup, the ComboBox should select the first item by default, so we expect the value to be 1. Finally, we verify whether the ComboBox is editable. In this example, the widget is configured as non-editable, which means the user can only select predefined values and cannot enter free text. By verifying these 3 properties, count, currentText, and editable, we fully validate the initial state of the ComboBox before modifying it. This ensures that the test is deterministic and that any later changes are performed on a well-defined and verified widget state. What's important here is that no mouse clicks or keyboard input are required. Zeno Test locates the widget, but the actual data comes directly from Qt. This makes the test more stable, faster, and independent of UI timing or screen resolution. Next, we use SetQtProperty to change the state of the ComboBox. By calling setCurrentIndex with the value 3, we directly select the fourth entry, 4. The ComboBox immediately updates its state without opening the dropdown or simulating user interaction. To confirm that the change was successful, we now read the widget state again. For this, we call GetQtProperty and retrieve the current text of the ComboBox. Finally, we verify the result. We use verify equal to check that the current text is now 4. This confirms that the ComboBox state was modified correctly using Qt property access. At the very end of the test, we close the application under test. For this, we perform a single left mouse click on the Windows Close button in the title bar. This control was already captured earlier during the recording step, when we manually closed the AUT. Because of that, no additional recording is required at this point. This step is only used for cleanup and ensures that the application is closed in a controlled and predictable way before the test finishes. Now we can run the test case. Zeno Test automatically starts the Qt Test app, reads the initial widget state, modifies the ComboBox selection, and verifies the result, fully automated. The execution log clearly shows each step and its outcome. And that's it. You've seen how GetQtProperty and SetQtProperty allow you to directly access and control Qt widgets without relying on fragile UI interactions. This approach is ideal for robust, fast, and maintainable test automation in Qt-based applications. Thank you for watching.